Hi everyone, I am Ryan Emparadina, an MSEM student. I am here to present to you my thesis proposal entitled Applications and Challenges of Adopting Internet of Things in Reducing Road Traffic Accidents. This is a partial requirement for Master Thesis 1 with the guidance of my advisor, Professor Marvin Norona. Here are the presentation contents or the research chapters. So we have three here. Chapter 1 is for introduction. Chapter 2 for review of related literature. And Chapter 3 for methodology.
Chapter 1 Introduction.
For Chapter 1 introduction, it composed of 6 areas of context that summarizes and gives you current understanding and background information about the research. These are the general area of interest, specific area of discussion, statement of the problem, statement of the purpose, statement of value, and the scope and limitation. The general area of interest and specific area of discussion focus on vehicular road accidents, which considered major cause of deaths after disease. According to the 2020 World Health Organization report on road traffic accidents or injuries, the lives of approximately 1.35 million people every year are cut short as a result of a road traffic crash. So imagine the impact of road traffic injuries and road traffic crashes as a global scale, on a global scale. It is supported that the human error as the main risk contributor, which are overspeeding, driver under the influence of alcohol, non-use of helmets, seatbelts and child restraints, distracted driving, unsafe road infrastructure, unsafe vehicle, and inadequate law enforcement on traffic. Another study made by Azeredo in 2018 concentrates that the New World Bank study finds that reducing road traffic deaths and injuries could result in substantial long-term income gains for low and middle-income countries. This means that countries that do not invest on road accidents could miss out anywhere between 7 and 22% in potential per capita or the GDP or the gross domestic product growth over a 24-year period, requiring policymakers to prioritize proven investments in road safety. Also, it mentioned that having deaths and injuries due to road traffic could potentially add 7% to the GDP per capita in the Philippines. Another news or report made by philcoche.com in 2020, recently, last year, telling us that the Philippines DOH or the Department of Health tagged road accidents as one of the leading causes of death, overtaking other deadly diseases, including dengue, in the list of causes of deaths. Reported in MMRS 2019 was the classification of accidents in Metro Manila into fatal with 372 cases, non-fatal with 20,466 cases, and damage to property with 100,933 cases. MMRAS means Metro Manila Accident Reporting and Analysis System was supported by the MMDA or the Metropolitan Manila Development Authority. This is a report being done annually since year 2005 up to present. In this report, it mentioned here the nature of accidents, which are swipe, rear end, angled impact, hit and run, multiple collisions, self-accident, hit parked vehicle, head-on, and hit object. Another study made by Tanggol in 2018 telling us that various improvements and plans to address these road accidents in Metro Manila included development of policies and implementation of programs on road safety, formation of a road safety task force, and harmonizing and modernizing of land transportation and related laws. But these issues remained on the effective enforcement of road safety laws. This means lack of national vehicle standards to ensure use of safer vehicles and building transport and road infrastructure. Upon the areas of interest and specific area of discussion, particularly in road traffic accidents, here's the emerging technology adapted, which is the Internet of Things, which might help on the application and to reduce the road traffic accidents. So the automotive industry was one of the first adopters of IoT in incorporating its applications in vehicle design and manufacture. Most common are sensors that detect failures in vehicle performance and anticipate mechanical failure while on the road. Another development using IoT in vehicles is the Advanced Driver Assistance Systems or ADAS, which increases road safety by a safe human and machine interface as it has sensors, cameras in order to detect any traffic obstacles, the man driving errors on which it automatically corresponds and adjusts to the events or situation. So this is a study made by Moller and Haas in 2019. ADAS is developed or used or is developed to automate and enhance aspects of the driving experience to increase safety and safe driving habits. According to the study of Sharman in 2020, connected technologies and the IoT are improving vehicle safety, efficiency, and convenience as well as the overall user experience. Based from the discussion of the general area of interest and specific area of discussion, we now come up with a statement of the problem or the research question. What are the applications and challenges of adopting IoT in reducing road traffic accidents in Metro Manila, Philippines? The study proposes to identify the major causes of traffic accidents where IoT applications can be viable to reduce the risk of vehicular accidents. The study also aims to come up with an IoT implementation platform in adapting IoT considering the vehicle-to-driver interface, infrastructure conditions, and environmental factors. The objectives of the study are: number one, to determine the significant factors affecting different nature of vehicular road and traffic accidents. Number two, to determine the focal areas of improvement where IoT can be implemented to reduce road accidents. And number three, to propose implementation of strategy in the reduction of road accidents and to identify whether IoT adoption is applicable to Metro Manila, Philippines. The results of the study will benefit to drivers, vehicle owners, pedestrians, and the policymakers and law enforcement. Stakeholders in the road system and traffic ecosystem will stand to gain from the advantages of IoT-enabled vehicle-related systems. Traffic management infrastructure and operations in minimizing human interface errors and consequently reducing road accidents with the use of internet, wireless communication, data analytics, and IoT platforms. It contributes to the field of IoT application in the area of transportation and road safety. For the scope and limitation area, it will utilize annual reports from 2005 to 2019 publicly released by Aras, which is discussed earlier, about the road accidents in Metro Manila. It is also limited in Metro Manila, the study, the largest metropolis in the country with the greatest number of registered vehicles and heaviest concentration of the business and trade. It makes it a suitable focus of the study where data is available in identifying the different nature of road accidents involving almost all types of main vehicles ranging from the private cars, transport buses, express vans, to delivery trucks.
Chapter 2, Review of Related Literature.
Chapter 2 is the review of related literature. This chapter is a collection of different sources like journals, industry publication, past studies, researches, books, and white papers that will serve as a review of related literature to substantiate and support the topic or problem discussed in Chapter 1. So I have collected 20 citations or 20 references But I will mention six major influence studies that helped me to come up with the research gap and the synthesis for the chapter 3, which is the methodology. The first one here is the study from Kim, or rather a report from Kim titled Road Accidents in the Philippines, Causes, Facts, and Latest Statistics, made by philcoche.com. The statistics in the report is also based on the MMRA source. This report emphasizes that though there are high number of vehicles on the road, accidents should also consider factors about infrastructures, people crossing or pedestrian, weather conditions, government policy, and more. The five causes mentioned are overspeeding, driving under the influence of alcohol, bad overtaking, improper turning, and jaywalking. For the research gap, lack of statistical study to support the significant factors identified affecting different nature of vehicular road and traffic accidents. The second study is made by Versosa and Miles in 2016, entitled Severity of Road Crashes Involving Pedestrians in Metro Manila, Philippines. Factors why there is an increase of road accidents are by motorized vehicle driver characteristics, vehicle attributes, environmental characteristics, and other social determinants or of pedestrian injury. The research gap is the lack of study on accessibility and safe pedestrian infrastructure to reduce road traffic accidents and focal areas of improvement. The third study is made by Richmond and Kyle in 2005 with the title Estimation of Socioeconomic Costs of Road Accidents in Metro Manila. So the researcher used human capital approach that concentrates on the gross output of the victims of road accidents and costs, classified to victim related costs, damage to property, and administration costs. What I found out here is the research gap, which it lacks of proposal or of implementation of strategy, how to reduce the damage cost based on the results. The fourth study is made by Jain, Chaudhary, and Srivastava recently this year in 2021. Their paper is titled The Fundamentals of Internet of Things, Architectures, Enabling Technologies, and Applications. According to this book, IoT are devices with program hardware, software, sensors, and network connections. The architecture of IoT has three layers: the application layer, the network layer, and the perception layer. The synthesis or idea of this book will help me on the chapter 3 methodology. Application of IoT technology can be used on vehicles that can improve and reduce the road accidents using the three layers for the conceptual or end operational framework. The fifth study was made in 2018 by Ni, Wei, and Shen. Their concept are or their paper study entitled An Internet of Things Based Intelligent Life Monitoring System for Vehicles. Features of this study like in-vehicle environment monitoring and emergency management were integrated for the purpose of effectively protecting the safety of the vulnerable people. Specific sensors like infrared and photoelectronic detectors were mentioned on which it can identify human body target and other objects. Will help gain information that can relate to the use of IoT. This concept can be related and addressed to human interface error problems like lack of alertness of the driver, driver under the influence of alcohol, and the in-emergency situation. The synthesis for Chapter 3 methodology here is that identify variables for the research framework under the IoT construct as the system design on this paper has life recognition subsystem which help detect the infrared energy emitted by the person's body to detect human body movement and sound the alarm. The last study was made in 2018 by Goyal, Lokeshwara, and Amalyal. The paper titled Design and Implementation of Real-Time Autonomous Car by Using Image Processing and IoT. A design and concept related to Advanced Driver Assistance System or ADAS about vehicle-to-infrastructure communication is studied to detect traffic signs and path identification. This concept can influence in reducing the road accidents caused by human interface. It will be an automatic identification of the situation in the surroundings. IoT is used to detect the images of the object and pedestrians using the image sensor. The synthesis for Chapter 3 methodology. The concept of this study will be used to the survey that will be conducted to gauge the perceived effects of potential IoT elements on the identified risk factors that can cause road accidents.
Chapter 3 Methodology.
The study will adopt the following conceptual framework as shown in this slide. So we have here three constructs: risk factors, road accidents, and IoT adoption and application. As its logic in finding an answer to the research question, identifying areas where IoT will be viable to introduce and adopt in Metro Manila in viewing of improving road safety after analyzing road accidents and its causes. Road accidents are a function of safety risk factors on the road that include the aspects of vehicle, driver, road conditions, environmental driving conditions, information, and other stakeholders. The study will look into the moderating effect of IoT on the relationship between risk factors and road safety, using the number, type, and nature of accidents in view of the study's overall objective of reducing road traffic accidents. The following hypotheses are hereby posited. So we have four. H10, there is no significant relationship between risk factors and road traffic safety. H1A, there is a significant relationship between risk factors and road traffic safety. H20, IoT adoption and applications have no moderating effect on the relationship between external factors and road traffic safety. H2A, IoT adoption and applications have a moderating effect on the relationship between external factors and road traffic safety. By the way, the H0 here is the null hypothesis and HA here is the alternative hypothesis. In order to test the above hypothesis, an operational framework is shown in this slide, together with the variables that will be the interest of the study as indicators of the three constructs contained in the conceptual framework. For this slide, I will be discussing the construct of risk factors, which has five variables, namely human interface, vehicular and mechanical related, infrastructure related, traffic management related, laws and law enforcement, and weather or environment. The indicator of human interface variable is the speeding, driving, under the influence of alcohol, failure to use equipment, unsafe and hazardous road infrastructure. For vehicular and mechanical related, engine is sputtering, wheel is shaking, brake grinding, failing failures, gearboxes issues, electrical problems, and so on. For the infrastructure related, highway and its geometric features, including alignment, roadside elements, sight distances, presence of guardrails, access points, roadway consistency, and additional variables that measure the overall quality of the highway alignment and elements. For the traffic management related variable, The indicators are the increasing traffic congestion and inefficient traffic management. Lastly, for the weather or environment variables, the indicators are visibility impairment, precipitation or fog, wet roads, and temperature extremes. The second construct is the IoT adoption and applications. It has three variables, which are physical layer, network layer, and the application layer. For the physical layer, the indicators are the data collector things or sensors, RFID, raw data, and real-time information. For the network layer variable, the indicators are internet and wireless connections, network infrastructure, main functioning units of the architecture. And lastly, the application layer variable. The indicators are intelligent computing technology, management services, authentication, and authorization. The last construct is the road accidents. It has three variables, namely fatality for deaths, non-fatality or injury, pedestrians and drivers, and damage to property. For the variable fatality, the indicators are 372 total number of fatal or deaths. For non-fatality or injury, 20,466 total number of non-fatal or injury is the indicators. And for the damage to property, 10933 total number of damages to property. So all of these are cited in the MMRS 2019 report with a total of 121,771 cases of road accidents. The study will mainly use secondary data that will come from the MMDA via their official MMRS report. Said report is a compilation of road accidents since 2015 categorized into fatal, non-fatal, and damaged property road crashes in Metro Manila. This data will be relevant and important in the analysis of the nature and causes of road traffic accidents, from which areas of potential IoT applications can be identified in view of the primary aim of the study to reduce the risk leading to traffic accidents. A survey will be conducted to gauge the perceived effects of potential IoT elements on the identified risk factors that can cause road accidents. The respondents of this survey are individuals who have driving skills and knowledge of traffic rules, and better yet, with the ability to express their thoughts on the risk factors affecting driving performance. The target number of respondents will be 300, and the validation of responses will be conducted with a pilot run with a small subset sample to see if questions are easily understood and provided via chi-square test of goodness of fit. To ensure the responses are usable, a set of demographic profiling questions will precede the main sets of questions related to the constructs. The questionnaire can be found in Appendix A of the document, where questions are drawn according to constructs and definition of variables tabulated as discussed previously. The use of secondary data from the annual MMRS report will be the basis of root cause analysis and will warrant the consequent use of ANOVA when these causes are translated into risk factors after a thorough classification of nature and cause of accidents. The use of ANOVA and multiple regression will enable testing for the first hypothesis of the significant relationship of different risk factors and road accidents with a p-value of 0.05 or a confidence level of 95%. Multiple regression allow us to look at the relationship between the variables while holding other factors equal and estimate the strength and significance of the relationships between the dependent variable of road accidents and the independent variables of the risk factors. The multiple regression will be used to check if the road accidents can be predicted based on the risk factors variables. The second hypothesis will be tested using the survey responses to the questions of how different IoT applications, if adapted, will mitigate the risk factors identified to have significant relationship with the road accidents. Since IoT application cannot be observed directly and measured with actual data, it will be the best to do a confirmatory factor analysis to determine if there is a perceived moderating effect of potential IoT applications in reducing traffic accidents. The said statistical tool will help in testing whether measures of a construct of IoT adoption and applications are consistent with the researchers' understanding of the nature of the construct or factor, since the premise taken is that IoT platform applications, based on the literature review, have a moderating effect. This is important in recommending an IoT application platform implementation approach in terms of those measures. The corresponding survey questions of each stones are outlined in Appendix A of the actual paper. The results of the two hypothesis tests will mainly be used in crafting an IoT platform implementation strategy, whether the results of the literature review or IoT technology developments and applications in the transport industry and traffic management. The platform strategy elements will be grounded in the context of Philippine land transportation policies and infrastructure, more particularly in Metro Manila, with the most number of registered vehicles, with the heaviest density of population among urban centers across the country, and with an alarming increase in road traffic accidents resulting in fatal, non-fatal injuries and damage to property. This will mean using the significance of corresponding risk factors to the nature and cause of road accidents, as well as the appropriateness of IoT application in mitigating the type of risk. Appropriateness will pertain to the results of the confirmatory factor analysis that will show the agreement between the perception of the respondents' interpretation of an IoT application as a risk reduction factor, and the researchers' understanding of the IoT application in mitigating the risk strongly associated with the nature and type of road accident. This step will reconcile the results of achieving the first and second objectives to the width or to the identifying the causes and nature of accidents and determining the areas of IoT to reduce road traffic accidents. Drawing the implementation platform will lay the foundation of adopting IoT in traffic management, specifically in reducing risk factors and consequently minimizing road accidents. The proposed implementation platform will have to include the challenges in IoT adoption, since many stakeholders are involved, especially government agencies, riding public, vehicle owners, and infrastructure developers, and ICT service providers. The proposal will come up with a holistic framework with a subsystem approach based on a key based on a based on key success factors in significant areas of IoT applications in reducing risk factors and road accidents. It will include as challenges need for policy reviews, minimum requirements on providing ICT services like mobile apps, the internet, IoT hardware and system interconnection, traffic regulations, law enforcement, and traffic management infrastructure, such as the signage, GPS, communication, and education. There are also challenges implementation of IoT in terms of Philippine readiness on the said technology. The study will be geared in looking Metro Manila as a pilot model for IoT applications for traffic management and accident reduction so that it can be emulated by other urban centers throughout the country and eventually throughout regional areas and the rest of the countryside. The budget will not be tackled but will of course be considered as one of the major challenges that will present or that will be presented as an initial hurdle that will be produce long-term benefits and sustainable efforts in reducing road accidents. A stakeholder view and system approach will be adopted in this final step not only to achieve the third and final research objective, but to contribute to the body of existing knowledge of IoT applications, particularly in the field of traffic management and risk reduction for a developing country with unsolved traffic issues and increasing road uh, accident rates that go with the pursuit of economic growth with technology advancement in improving the lives of its citizens. This is the end of my presentation. Thank you for watching and thank you for your time. For any questions, please send me a message to my email ryan.paradina@gmail.com.